A packet tracer puzzle. Use PC1 in the green box to access the hidden network and figure out how the network in the cloud is wired and configured. Okay, this is PC1 on the green section, and this cloud is the hidden network. Okay, obviously it's locked. Okay, this is the PC1. For security purposes, some ICMP functions have been disabled, so ping is not allowed. All VTY passwords are Cisco. Enabled passwords are not available. So use the OS and iOS command line functions for the following. Part 1. What is the MAC address of the cisco.com server in the hidden network? Okay, in this cloud there is a server with the name cisco.com. So you need to know the MAC address. You need to find the MAC address. Okay, and part 2, using the devices, recreate the network that is in the hidden network cloud. Okay, using these devices, recreate the network in this cloud. When complete, all PCs should be able to open the web page at cisco.com, and each device should be able to ping all other devices. The items graded are interface configuration, proper cable and connectivity, static routes, bandwidth, switch configuration, and routing. Some helpful commands: redistribute static subnets, show IP interface brief to know the IP addresses, show IP route to know the network addresses and routes, show IP protocols to know the routing configurations, show IP ARP to know the MAC addresses and IP addresses, and show controllers to know the clock rate, show CDP neighbor detail to know the Cisco neighbor devices, show interface serial to know the bandwidth or interface configuration. Okay, these are the same instructions. Do the following first. You can insert your profile, okay, your name or email, but go to preferences, show device model labels, show device name labels, and show link lights, show port labels when mouse over in logical workspace. Okay, and close this. Now you can see the names and models. This is very important to recreate the network. You will see. The first step is this is PC1. So there is a PC1 here. Okay, PC1, and go to the real PC1. Go to desktop, and you can see the IP configuration. IP subnet mask, default gateway, and DNS server. Go to PC1 and the same configuration. Okay, so this is PC1. Okay, and go to the real PC1 on the green section. Go to command prompt and verify the IP config. Okay, The IP address, this is the default gateway. The default gateway is the next router. So connect the next router using telnet. So that's why all BTY passwords are Cisco. So BTY is enabled for telnet. Okay, telnet, and this IP address, the router, enter. The password is Cisco. Enter. This Phoenix router. So you can see this is Phoenix router. This, okay, and PC1 is connected to Phoenix router. Okay, go to Real PC on the green section, and you can verify some. Configurations, and try to use enable. And it's not available, so there is no password for this. Okay, Control C or enter. If you don't have the enable password, you will not be able to access the privilege exec mode. So only you can use the user exec mode. Okay, so you have some limitations. But anyway, there are a lot of commands that you can use. For example, show IP interface, show IP route connected. Now you can see 4 directly connected networks. 4. These are the interfaces: fast Ethernet interfaces, serial interfaces, the network addresses. Okay, and you can use also show IP interface brief. Okay, you can see the host, the interface host IP addresses, and you can see, for example, on fastnet.00, this is the IP address, the host IP address on fastnet.00. But on fastnet.00 also you can see the network address and prefix or subnet mask. And for example, on serial 000, this is the IP address of the interface, the host IP address on the interface 151. But on serial 000, you can see the network address and prefix and subnet mask. So you need to know the difference between host address and network address. Okay, very nice. So you can document this. Okay, first this fast Ethernet 01. Okay, with the host address on fast Ethernet 01 is 180. 180 on fast Ethernet 01. But now you can see the configuration on the PC. On PC1 is 192.168.10.10. So this is the network for PC1, 192.168.10. 107. This is the IP address of the interface fast Ethernet 00 on the router. But this is the network 192.168.10.0.24. On fast Ethernet 00. This is the network for PC1. Okay, you can use this. Control B. The PC is number 10, and fast Ethernet 00 on the router is 107, as you can see. Okay. And So PC1 is connected to FastEthernet 00. Okay, this is a 1841 router, is an old router. So I will use a crossover cable between PC and this router, Phoenix router 1841 on FastEthernet 00. Okay, and you have the network address, the host IP on PC1, the host IP on FastEthernet 00. This is for FastEthernet 01. This is the network address. Okay, and very nice. Okay, this is very good. It's much better. And now, two more networks on serial 000. This host, but serial 000. This is the network address. Serial 000. On serial 000, the host is 151. 151. Okay, very nice. For serial 001, this is the host is 66. Serial 001, this is the network address. The network address. And you know the host on the IP on the interface is 66. Serial 000, serial 001, Fast Ethernet 01, Fast Ethernet 00. Okay, very nice. Okay, I have the 4 directly connected networks, 4 interfaces, 1, 2, 3, 4. Very good. And use the following. Go to the real network here. Click on PC1 on green section. Show CDP networks. Now you can see the Cisco devices, the network Cisco devices, Chicago and Denver. Okay, Chicago and Denver. Okay, the networks, 2 networks, or maybe here, I don't know, but anyway, I will place here. Okay, and Chicago is 1841 router. Okay, Chicago 1841, and Denver is 2800. Okay, 2800 series. Okay, very nice. But you can see the local interface on Phoenix. On Phoenix, the local interface is serial 000, and on Chicago is serial 000. Also serial 000. Okay, and also you can see more details. For example, show CDP network detail space. Okay, this is Chicago. The local interface is serial 00 on Phoenix, but on Chicago the interface also serial 000. Okay, this is the IP address on Chicago. Okay, 218.13.227.149. Okay, 218.13.227.140. Okay, this is This is Chicago. Okay, this is very nice. This is the network, and Chicago on serial 000, Chicago is 149. 149. Okay, but I need to know the DC for the serial connection. Maybe it's here on Phoenix, or maybe it's here on Chicago. I don't know. So now you are on Phoenix, and you can use on local interface on Phoenix local interface serial 000. You need to know the clock rate, if this device is DC, if this interface is DC or DT. Okay, show controllers serial 000. Okay, on Phoenix serial 000, show controllers, enter, is DC. Okay, so DC is placed on Phoenix. Okay, Phoenix serial 000 is DC. Okay, and the another side. Okay, Phoenix serial 000 DC. So on Chicago serial 000 DT. So go to this interface serial DC with clock here, down here, and first click on the DC on Phoenix serial 000 and Chicago serial 000. Very nice. Okay, from serial 000 to serial 000. And now to Denver on Phoenix serial 001, but on Denver serial 010. Okay, but on serial 001 verify the DC. Okay, on serial 001 on Phoenix show controller serial 001, enter the DC, also DC. Okay, go to Control C, Control B. This is also DC. Okay, serial 001. Okay, and connect from Phoenix serial 001 to Denver serial 010. Again, the serial DC with clock rate. And serial 001 to Denver serial 010. Be careful. And also you can see the host interface on Denver 204.53.87.65. 204.53.87 and 64 is the network address. So 65 is the host address on serial 010 on Denver. 65 and 65. Okay, very nice. Okay, and now this you have on Phoenix you have only two Cisco neighbor devices. Okay, two neighbors, two Cisco devices as neighbors, but you need this network, this directly connected network. Maybe here there is a PC or non-Cisco device. But anyway, you can review these PCs, for example, PCB, this IP address 87.34.129.135. For prior knowledge, this host 135 does not belong to this network. Okay, so PCB does not belong to this network. Okay, and review PCP desktop IP configuration and PCP and 87.34.129.182. So 182 belongs to this network. For prior knowledge, for VLSM or addressing using this subnet mask, you can allow the range of host addresses. This is the network address, but if you know the network address and the prefix or subnet mask, you can allow the range of host addresses. And PCP IP address 182 belongs to this network. So PCP should be here. And you know, on Phoenix, facade.01, this is the host address on the router 180, and the network address is 176. The network is 176. The IP on facade.01 is 180. So connect facade.01 to the PC using crossover cable. Facade.01 to PC. Okay, and the PC IP address is 182. Control C, Control V. 182. Very nice. So this is very good. Okay, or you can place for better. Facade.01. Okay, and now so for me this is ready, and maybe another information for now this is enough. Okay, so okay, I will go to Denver, connect to this interface 65 204.53.87.65 using telnet. Okay, telnet. Okay, is this 104? Is this? Okay, but it's 65. Okay, 65. I'm trying to connect to Denver. Okay, and from Phoenix, telnet Denver. From Phoenix, telnet Denver. Then go, enter. Password Cisco, enter. Now you are on Denver. And repeat. Show IP route connected, show IP interface brief, show CDP neighbors, show CDP neighbors detail, and show controllers. Okay, repeat all. Show IP route connected. 3 directly connected networks. on serial 000 this network address. Okay, on serial 000 this network address. But to know the host address, the IP on serial 000, show IP interface brief. This network on serial 000 and serial 000, the IP is 222. Okay, on serial 000. Okay, and this on fast address 01. Okay, on fast address 01, this network. Remember, this is network address, not host address. Okay, network address. Very nice. Fast address 01 and the host address on fast address 01 is 155 on fast address 01. 155. Okay, and the third 204.53.87.64 prefix 29 on serial 010. Is this serial 010 is the connection to Phoenix? So this is ready. Okay, 1, 2, and 3 directly connected networks. 1, 2, and 3. 1, 2, and 3. Okay, show CDP neighbors to neighbors, Lex and Phoenix. Phoenix is here, but add Lex. This is Lex. Okay, Lex is an 1841. Okay, 1841. And verify the detail. Show CDP neighbors detail. Space. Okay, and this is the host address 50, 12, 122, and 221. So the host is 221. On the another side, on lags 221. Okay. On Denver 222, on lags 221. Okay, and on Denver is serial 000, and on lags is also serial 000. Okay, but you know, you need to know the DC. Show controllers serial 000. Okay, this serial 00 on Denver serial serial 000. Enter DC DCE. Okay, DC Control C, Control V is DC. Okay, and so connect from Denver serial 000 to lag serial 000. Very nice. From here, from Denver serial 000 to lags serial 000. Very good. And also you can see on Denver only two Cisco neighbors. Okay, lags and Phoenix. Lags and Phoenix. And this is for a non-Cisco device or maybe a PC. Okay, so review the network address is 87.34.129, 144. Okay, prefix or subnet 28. Okay, verify PCB is 35, and 35 does not belong to this network. Okay, you know, for prior knowledge for BLSM and addressing, review this DNS server, the 87.34.129, 156. This is prefix 28. The default gateway is 155. Okay, the default gateway is 155. This IP address, this host IP address belongs to this network. Okay, so DNS should be placed here. And remember on FastEthernet 01. FastEthernet 01. Use 28 is not an alt router, so you can use straight through cable. FastEthernet 01 to the server. Okay, ready. And the IP address of the server is 156. Control C, Control V. 156. Very good. This is much better. And so on. Okay, now access to lags. 221. 5012, 122, 221. Okay. Space down arrow. Okay, from Denver, telnet lags 221. Telnet, okay, lags. This is lags IP address. Lags, and this is the IP. Enter. Password Cisco. And this is lags. Very nice. You are on lags. And repeat the commands. Show IP route connected. 3 directly connected networks. Serial 000. This is the network. But this is already implemented. Is this? Okay. So this is ready. And now add this on FastEthernet 01 and on FastEthernet 00. Okay. FastEthernet 01, this network. Okay. For FastEthernet 01, show IP route, show IP interface brief. On FastEthernet 01, the host is 171. And on FastEthernet 00 is this. Okay, and the host is FastEthernet 00 193. Okay, very nice. And now 3 directly connected networks. 1, 2, and 3. And now show CDP neighbors. Only one device, Denver. Only for lags, only one device, Denver. Only one Cisco device is Denver. Okay, very nice. Okay, so here and here on fast Ethernet interfaces should be non-Cisco devices or PCs or servers. So verify PCB 87, 34, 29. Okay, 135 does not belong to this network, also does not belong to this network. Review Cisco server. 87, 34, 129, 173, default gateway 171. Okay, default gateway 171, very nice, and 173 belongs to this network. Okay, so Cisco should be placed here on Fast Ethernet 01. On Fast Ethernet 01. So use a crossover cable. Fast Ethernet 01. And this Cisco device is 173. 173, very good. Okay, and search PC for this network. This is a router, this is a switch. Review the switch. This command line interface, enter, enable, show running config. No IP configuration, so okay. I cannot find a device for this network. Okay, let's see what happens. Okay, exit from lags. Exit from lags. Okay, this network is pending. Okay, exit from lags. Okay, exit. Now you are on Denver. Okay, this is Denver. Exit from Denver. Exit from Denver. Now you are on Phoenix. You are on Phoenix and connect to Chicago. Okay, 149. Okay, telnet. And this IP 218, 13227, 149. To access Chicago. Okay, enter password Cisco and repeat the commands show IP route connected. 3 directly connected networks on serial 001, 1833. Okay, this network. Serial 001 copy. And paste the host show IP interface brief. And 18 serial 001, the host IP on the interface is 100. Okay, very nice. And 144. Okay, this another network on Fast Ethernet 01, 144. Okay, Fast Ethernet. Okay, here on Fast Ethernet interface, Fast Ethernet 01, on Fast Ethernet 01, the host the IP address of the interface is 225. Okay, very nice. Okay, but wait a minute. What is going on here? Look at this. these are the same. These are the same. So these devices should be connected. Okay, Chicago should be connected to LAX. Okay, but okay, so Chicago should be connected to LAX. Okay, using fast Ethernet interfaces. But for some reason, LAX did not detect Chicago as a neighbor. Okay, for some reason, LAX did not detect Chicago as a neighbor. So I will remove this. Okay. Remember, you are on Chicago. Okay. 18 network is this. 144 network is this. And 218 network is this. Okay, 3 directly connected networks, 1, 2, and 3. Okay, and use show CDP neighbors. Okay, for Chicago, only 2 neighbors, Phoenix and Bang. Okay, for Chicago, only 2 neighbors, Phoenix and Bang. Okay, this is Bang. Okay, but for some reason, Chicago did not detect LAX as a neighbor. Okay, for now, I don't know why, but I think Chicago should be connected with LAX for this network. Okay, they are sharing this network. Okay, and on Chicago, show CDP neighbors detail space. Okay, this is Phoenix 151. This is Phoenix 151. But this is Bang 18 network, but 121. Okay, Bang 121. 121. Okay, and ready. And on Chicago, the interface is serial 001, with the Bang is serial 00. On Chicago, serial 001, on Bang, serial 00. But verify the serial 001 on Chicago. Show controllers serial 001 is DTE. So the DCE control C control V should be on Bang. Okay, and if Chicago serial 001 is the DTE, that means that Bang is the DC. Okay, and connect. So connect from fields, connect from Bang serial 00 to Chicago serial 001. The order of the connection is very important here. First connect from Bang serial 00 to Chicago serial 001. Okay, go to the serial DC, this cable with the clock, and first on the DC serial 00 on serial 001 on Chicago. Okay, very nice. And this is ready with this connection. Okay, Chicago. Okay, this network 144 is the connection from Chicago to LAX, and it's using Fast Ethernet 01. Fast Ethernet 01. Okay, but I need to know the Fast Ethernet used on LAX. Okay, it should be up here on LAX. Denver, Phoenix. Okay, where is LAX? Okay, here is LAX. 144. This is the network with Fast Ethernet 00 144 network IP 193. 193 network 144 Fast Ethernet 00. Okay, I will use crossover cable from Fast Ethernet 01 on Chicago to Fast Ethernet 00 on LAX. Okay, Fast Ethernet 00 on LAX. Okay, and Fast Ethernet 01 on Chicago. Fast Ethernet 01 on Chicago, Fast Ethernet 00 on LAX. Okay, very nice. Okay, but also you can see the progress to verify. Okay, completion 13%. This is very good because there is some progress. So this is very important that you are doing a very good job for now. So also you need to configure the interfaces here to recreate all the network. Okay, but for now go to access bank 121. Okay, from Chicago telnet to bank. Okay, where is the bank IP address? Is bank, this is the IP address. Down arrow telnet. Okay, 1833 157 121. This enter Cisco. Very nice. You are on bank. Okay, on this router. Repeat the commands. Show IP route connected. Two directly connected networks. 18. This is 18. Is ready. But another 87. This another network address. Okay, 87. But on Fast Ethernet 00. Fast Ethernet 00. And show IP interface brief. Fast Ethernet 00 is 131. 131, very good. Okay, and maybe here should be a PC, but verify using show CDP neighbor. only one Cisco device's neighbor is Chicago. Okay, for bank, the only one neighbor is Chicago. Very nice. So it should be here. It should be a PC or another verify PCB. Click here on PCB. Okay, look at this. The default gateway 131. This host address 135 belongs to this network. So PCB should be here and should be connected to fast Ethernet 00 using a crossover cable. Fast Ethernet 00 to PC. And PC IP address is 135. Okay, 135. Okay. And this switch is missing. This switch is an old 2950 switch, but I don't remember if there is a switch as neighbor for these routers. I don't know where to place this device, but I think should be placed here. So that's why Chicago is not able to detect a neighbor, and also that's why LAX is not able to detect Chicago's neighbor. Maybe this device is placed here because okay, but I will try. Okay, I will try using the progress. Okay, verify the progress here. Completion 15%. Okay, if I will place this device here, I will connect the routers to the switch, and the progress should be higher than 15%. Okay, so remember on Chicago is fast Ethernet 01 and on LAX is fast Ethernet 00. Chicago 1, LAX 0. Okay, I will remove this cable and use copper straight through. When Chicago is 1, fast Ethernet 01. Use any board, for example, port 1. And on LAX, fast Ethernet 00. Any port, for example, fast Ethernet 2. And verify the progress. Now is 18. Okay. Before was 15 and after is 18. So this switch should be placed here. Okay, very good. Very, very good. Okay. Okay, very nice. And now, this is the topology. This is the complete topology, but the progress is 18%. So you need to configure the devices. Configure Phoenix. Enable configure terminal. The fast Ethernet 00 interface is this. Okay, interface fast Ethernet 00. IP address 192.168.10.107. Prefix 24. Is this subnet mask 0? No, shutdown. Okay, the fast Ethernet 01, this interface fast Ethernet 01 with this IP. Okay, fast Ethernet 01. Fast Ethernet 01 IP address 87.34.129. Be careful. It's not 176, it's 180. Prefix 28 is 240. No shutdown. Serial interfaces. Okay, first serial 000 is this 151. Okay, interface serial 000. IP address 218.13.27.151. Prefix is this 28. 240. Be careful with IP addresses. Review always. Enter. Shut down. The another side serial 001. Okay, with this IP 66. IP address 204.53.87.66. 29 is 248. Okay, review the IP to avoid problems and shut down. Okay, very nice. And this is ready. And okay, and now configure Chicago. This router. Okay. Enable configure terminal interface. Okay, serial 000. Okay, IP address 218.13.227. 149. This IP, remember, this IP 149. Prefix 28 is 240. Let's shut down. Enter. The another interface serial 001. Okay, enter serial 001. IP address 18.33.157. Be careful. 27 is 224. Review the IP. Very nice. Not shut down. This interface 225. Interface. The interface is fast Ethernet 01. Fast Ethernet 01. IP address 144.233.17.225. Okay, review this and be careful. Very nice. Prefix 26 is 192. No shutdown. Very nice. Now configure bang. Enable configure terminal interface. This interface serial 000. Serial 00. Only 00. IP address 18.33.157. 121 224 33 157 no shutdown. And this IP for fast Ethernet 00, for fast Ethernet 00, IP address 87.34.129.128.131. Okay, this IP 131. Review the IP. Very nice. And prefix 28 to 40. No shutdown. Very good. Now configure Denver. Enter enable configure terminal interface. Okay, serial 010 IP address 24 53 87 65. Okay, 204 53 87 65. This and prefix 29. The prefix 255 to 48. 29 is 248. Shut down. And this another interface serial 000. Okay, enter serial 000. IP address 50 12 122 and 222. Okay, review the IP 5012. Okay, and prefix 30 is 252. Shut down. And don't forget the fast Ethernet 01. The fast Ethernet 01 IP address 87.34.129.155. Prefix 28 is 240. Okay, review the IP. Very good. Prefix 28 240. No shutdown. Okay, and finally Lex. Enable configure terminal. Okay, this interface serial serial 000. Interface serial 000. IP address 5012 122 221 255 255 255 252. Shut down. Okay, and this another interface fast Ethernet 00. Fast Ethernet 00. IP address 144 233 17 193. 26 prefix is 182. Review the IP. And very nice. Enter shutdown. And don't forget fast Ethernet 01. Fast Ethernet 01 IP address 87 34 129 171 255 255 255 240. No shutdown. Enter. Okay, review. Okay, ready. Very nice. Review the progress. 62. This is very good. But you need to configure the routing. You know, you need to implement a static routing or dynamic routing to network convergence. Okay, and review the routing on Phoenix. Okay, go to the real network. Click here on PC1. Remember, this is PC1. I am on BAM. Okay, but go to Phoenix, exit. You are on Chicago, exit. Now you are on Phoenix, and on Phoenix use show IP protocols. And now you can see routing protocol is OSPF with ID one process ID 155. Okay, go to Phoenix, enter, exit, router OSPF process ID 155, enter. Okay, the process is 155. Router ID 9. Go to Phoenix, router dash ID 9. Okay, 4 nines. Okay, and okay, these are the networks. Okay, 4 networks because Phoenix has 4 directly connected networks: 1, 2, 3, and 4. So that's why you are configuring 4 networks. I will do the following. I will use a notepad and add the keyword network. Okay, and only copy this to Phoenix, paste. Now you can see this configuration, enter. You are configuring the 4 directly connected networks on OSPF, or you are advertising 4 networks for OSPF. Okay, this is very nice. You can see the progress to verify 69. So I'm doing a very good job. Okay, and go to from Phoenix, go to Denver. From Phoenix, go to Denver. Denver is 65. Okay, is this 65? Very nice. Enter. Cisco. Okay, you are on Denver, here on Denver. Use the same show IP protocols. Process ID 155, router ID 1. Okay, go to Denver, enter, exit, router OSPF 155, router dash ID 1. Okay, 155. Okay, very nice. And the networks. These are 3 directly connected networks. 3, 1, 2, 3. Okay, and add the network keyword. On Denver, paste, enter. Very nice. And from Denver, access to lags. Okay, from Denver, access to lags. Lags is 221. Telnet 50 12 122 221. Okay, enter. Cisco. Now you are on lags. Okay, show IP protocols. 155, router ID 5. Okay, on lags, exit router OSPF 155 router dash ID. Okay, and 5 on lags, 4 5s, and okay, router. Sorry. Okay, very nice. The process, the router ID. Don't forget 3 directly connected networks. Copy 1, 2, and 3. Okay, copy, lags, paste, enter. Okay, 3 directly connected networks advertised on OSPF. Very nice. Now go to Chicago. Okay, exit from lags, exit from Denver. You are on Phoenix. Connect to 149 for Chicago. 149. Is this 149? Enter. Cisco. You are on Chicago. Show IP protocols. Show IP protocols. Okay, 155, 7 on Chicago. Enter, enable, configure terminal, router OSPF 155, router ID 7. Okay, 7. This is the 3 advertised networks. Network. Okay, on Chicago, paste, enter. Okay, very nice. Okay, this is the adjacency with Phoenix. But look at this, redistributing external routes from static. Okay, and this should be a redistribution and a static route, so you can verify. Show IP route, show IP route, space. This is a directly connected network, 4C, directly connected network, another directly connected network, OSPF, 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 but this is the static. You can see a static. You need to configure this static on Chicago. Okay, this is static, and copy this network, copy, and on Chicago, enter, exit, and IP route, paste this network, that is this. Okay, a static route to reach this network. Okay, on Chicago, but obviously you need to add the, if this is the network, the destination network, add the 28 prefix. 28 prefix is 255, 255, 255, 240. But directly connected static route using serial 001. Okay, on Chicago using serial 001. Enter. Okay, very nice. But redistribute this on OSPF. Okay. Okay, access to router OSPF 155. Redistribute static subnets. Okay, remember this command, redistribute static subnets. Okay, redistribute static subnets. And show IP protocols. And you will see OSPF 155 router ID 7, redistributing external routes from static, routing for networks, 3 networks. Okay, now it's the same, as you can see. OSPF 155 router ID 7, redistributing external routes from static, 3 networks. Very nice. Okay, and review the progress. 89, very nice, very nice. I am close to 100. Now configure bang. Okay, but from Chicago telnet to bang. Bang is 121. 1833, 157, 121. Password Cisco. Okay. On BAM, show IP protocols. And no OSPF configuration. Show IP route. 2 directly connected networks and 1 default static route. 1 default static route. Okay, so on BAM, configure the default static route. Enable configure terminal IP route. Quad 0, the default static route. And is a directly connected static route using serial 00. Enter. So that is enough. Now you can see the progress. 91. Okay, very nice. Okay, verify test command prompt on this PC1, the recreated PC1, not the real PC1. The real PC1 is this, okay, but the recreated PC1, command prompt, ping to this PC, PCP, okay, 87, 34, 129, 182, enter. Success. Ping this DNS server, this IP address from the recreated PC1. 87, okay, 87, 34, 156, okay, ping to the DNS server. Okay, success, very good. Ping to PCB 135, PC1, 87, 34, 129, 135. Okay, ping to PCB. Very nice, very good. And ping to Cisco server 173. 87.34, 139, 173. Enter. Success. And now, finally, go to check results to know what is missing. This activity is incomplete. Please try again. Assessed items is blocked. Is not available. Assessed items. Connectivity test is available. Connectivity test correct to Cisco server, correct to DNS server, but incorrect for switch and switch 000 IP. Maybe you need to configure an IP for the switch, an IP address and default gateway. Okay, close this, close. Access switch 1. Enable configure terminal. Remember, no IP address configuration on VLAN 1, but I will configure an interface VLAN 1 IP address. I will configure this IP on this network. 193 is in use, 225 is in use, but I will use, for example, 194. 144, 233, 17, 194. The subnet is 26, 285, 285, 285, 192. Okay, enter. Now shut down. Exit. Configure the default gateway IP default dash gateway. And for example, I will choose this 225 on the switch 144, 233, 17, 225. Okay, review, enter. Very nice. Review the progress. Where is the progress here? 94. This is very nice. I'm close, very close to 194. Okay, but remember part 1. What is the MAC address of Cisco.com server? Okay, go to Cisco.com server, but not the MAC address for this Cisco recreated server. The MAC address for the Cisco in the cloud. Okay, the MAC address for the Cisco server in this cloud. So go to LAX, but in the hidden network, on the real network, you are on bang. Okay, exit from bang, exit from Chicago. You are on Phoenix. From Phoenix, access to directly to this IP, or maybe to Denver. Okay, 149 is 149. Is this? Oh, okay. Okay, 65 is Denver. Cisco. Okay, you are on Denver. Access this IP on LAX. This IP on LAX. Telnet 50, 12, 122, 221. Enter Cisco. Now you are on LAX. You can see you can just show IP ARP. The IP address of Facet 01 is 171. 171, this is the MAC address. But okay, 193 is this interface for Ethernet 00. 225 is this. Okay, and try to ping cisco.com from lags, but on the hidden network. Ping 87, 34, 129, 173. Ping to Cisco server. Enter. Okay, you know ICMP protocol is disabled. Okay, on the real network. Okay, but try to ping cisco.com server and repeat the previous command, show IP ARP, and now you can see this. This is the server 173. So this is the MAC address, my friends. Copy. This is the MAC address of the Cisco.com server. Okay. Okay, but when you have determined the MAC address of the Cisco.com server, use the first 4 digits as the IP address for this PC. For example, if MAC address is 124.1.234, IP address should be 1.2.3.4. Okay, and you know the MAC address is 7245. Okay, so access this PC and configure the IP 7245 and use any subnet mask. Okay, close this. Verify the progress. 95%. This is very good. Okay. So I don't know what is missing. I don't know what to configure to get 100%. But this is very good for me. More than 90% is very good. And you have the network convergence. Okay, PC1 can ping another PCs and servers. You have the configuration for this. So thank you very much. My friends.